Hello, and welcome to my submission for Introduction to Virtual Reality Creative Project number 2. My project is inspired by the mission of SpaceX to create a self-sustaining colony on Mars. In terms of purpose, I think this would fall under the category of education and training, given that it's basically a scientific simulation, with the idea being that it could be applied to some sort of training program for potential people who will live on Mars one day. The visuals for my project were inspired by this visualization video that SpaceX released on its YouTube channel a couple years ago. I built upon my creative project one, so I included the demonstration video here so you can see the state of the project before I began creative project two. As you can see, I have a character controller that is based on the direction the camera is facing in combination with a pretty cool camera system that I have using Unity Cinemachine to transition between virtual cameras for the player and rover script, as you can see here, and also for the drone. The character is not animated yet, as you can see. The first step towards getting my character animated was the rigging process. For this, I just used the Herc model as we did in the class tutorials, and I basically took my character and all the existing geometry on it and applied it to the Herc model um, for the sake of implementing the animations as easily as possible. The next step was working with Unity's animator to get these animations working in game. As you can see, I used a blend tree the same way in the tutorial where the animations will blend smoothly between idle, walking, and running based on the move speed that changes with the acceleration. On the right here, you can see my player movement script to sort of get an idea of how the player can move in 8 directions based on the direction the camera is facing, with the player snapping to face the movement direction. And then you can see how I use the set float function with the animator to set the speed value, which is going to impact which animation is playing. I added some particle effects for the jetpack, which was pretty easy given my experience in Unity, but I included the calls to play the particle effects in the code, where they are in the hierarchy, and as much of the settings I could show you here. The next goal for this project was adding AI navigation. So the first step was laying out the nav mesh, and I just included a screenshot of the nav mesh baked into my scene here. If you look at the hierarchy on the left, you can see how I've organized all of these empty game objects for the patrol points, which is going to be relevant in the next slide. There are two types of behaviors for the AI navigation. One is just patrolling randomly between all of the different patrol points in the scene, and then there's another that goes in that patrols between the different points in a specific order. I should note that the humanoid agents on my nav mesh are basically the same character as the player. Just I duplicated that object and removed the player script and added these scripts, but with the same animator. So as you can see in these scripts, I am also using the anim.setFloat to get these AI agents animated walking around the scene just like the player. Here's my pause menu. This was actually included in my Creative Project 1, but it was one of the requirements for this rubric, so I figured I would show it now and show how I implemented that in the UI script there. The most notable part of the code here is that sensitivity method, which is how you take the data that's on the slider UI element and actually apply that to the in-game sensitivity. Now that I've gone over all the things that I've added to my creative project, here is the final demonstration for my Mars-based simulation.